Hey guys, welcome back. So last time I have discussed about the three ways that we can create the deep learning neural network using TensorFlow library. Now if you are new to my channel, I have pasted that link in the description. Please check out that link so that you can get to know the basics as how you can create your neural network using TensorFlow library. Now here we are going to discuss about the advanced method. So the advanced method that is called as subclassing API method. So the reason that we are going to call it as an advanced method because we are going to create a class which inherits by my keras.models.model class. Hence, I'm going to say it as a subclass API method, and this is one of the advanced method, guys. Now to get the intuition as how each individual layers works, so to understand in depth, you should have seen my previous video, then only you'll be able to follow along. Alright, so make sure you check out that video and then come back to this video so that you can get the best benefit out of this particular video. Alright, so without wasting much time, let's get started, guys. So I'll come back to the documentation page of Keras. So here if you look at it, we have something called as model class. So this model class is given by tf.keras.model. Now inside this, this documentation clearly says there are actually two ways to instantiate a model. One with the help of functional API, where you start from the input, and using this input we are going to chain the layers to specify the model's forward pass, and finally recreate our own model from inputs and outputs. And this is what we have covered in our previous session as well. We have seen how to make use of functional API as well. And the other method that we have over here, that is called as subclassing the model class. So to do this, I'll make use of class inheritance. Now to implement the same here, the documentation clearly mentions, first I'll have to define the init method. And here inside this init method, we can specify how the model should behave. And then we should specify how those individual layer works. We have to specify it inside this call. So how the forward pass should happen, we have to mention it inside this call method. Now here in the documentation page, they have given an example. So we'll import TensorFlow as TF. Now this is followed by, we have to create it model as a class. So in this example, they have created class myModel, and this is inheriting from tf.keras.model. And inside this class, I have my init method. So this init method says def init self, alright, and whatever the arguments that I am receiving, I am sending it for my superclass. And then I have defined my dense layer, so self.dense1. So for this, I have defined my dense layer with 4 units of neuron, and the activation is ReLU. And in the second dense layer, this contains 5 units of neuron, and the activation is softmax. And how this layer should operate, that I have defined inside this call method. In the call method, I have mentioned as x is equal to self.dense1 of inputs. So whatever the data that I'm receiving as an input, I'll be sending it over here for my dense layer, and the output that I'm sending it for my x. And while returning, I am applying the dense2 layer, and this dense2 layer is being applied on my input data of x. And finally, I'm going to return the output for this model. So that is how the model has been built. So in my first dense layer, I'll be having 4 neurons. Okay, so each neuron has the activation of ReLU. And in my second layer, I'm having 5 neurons, 3, 4, and 5, and the activation is softmax. So this is my network architecture that I'm having. So whatever the input that I'm receiving through my input layer, so that is connected to my dense layer, and this is connected to this next dense layer. So in this way, we can create our own model using this subclassing API. So let's do one thing. Let's implement it for our example as well. Now, if you look at our code, so I have written the code that would look like this. Now, in my example, I have created a class as myDeepModel, and this is inheriting from this keras models.model. And this is being followed by, I have created my init method. So I'm overriding my existing init method, and here in this init method, I'm defining as per my requirement. So I have mentioned as units as 10, which means the number of neurons by default I'm setting it to be equal to 10. which is different from what we have seen in the documentation. And the activation, I am specifying it as ReLU by default, and I have mentioned as keyword arguments, which is a dynamic keyword arguments. So inside my init method, whatever the other keyworded arguments that I am receiving over here, apart from units and activation, I am sending it for my parent class init method. So this would take care of all the other parameters, which will be handled by default with the existing parent class. Then in my next hidden layer, I have mentioned as dense number of units, which is same as what we actually send as an input for us init method. And the activation is activation that I send. And in the second hidden layer, it's the same scenario, guys. And in my third layer, so here I have mentioned something as in main output, and this has a dense layer which has single neuron without any activation function. And there is another layer that is called as sub output, and for this sub output layer, it is also a dense layer with single neuron. Now let's look at the call method where I'm performing this forward pass. So forward pass is nothing but finding the y hat for my input data. So in order to find it, first I'm getting the inputs. So whatever the inputs that I'm getting, I'm separating into two parts, input A and input B. And once I have two inputs, input A and input B, I'm sending my input A into my hidden layer H1. So I'll say input A is being sent to my hidden layer H1. Okay, so you can clearly see I'm separating my inputs, and then hidden 1 is equal to self.hidden1. Self.hidden1 is what I have defined earlier. So on this hidden 1 layer, I'm applying my input A. And then this hidden 2 layer, which is present over here, is being applied on my hidden 1. So H1 is connected to my H2. Then I am performing concatenation between my H2 and my input B. So I have something as input B, and I'm performing this concat. So I'll say this to be a concat. And after this concatenation, I'm applying this main output on this concat. So whatever the output that I'm having over here, so I'll apply it to this main layer and I'll get the main output. And again, what I'm doing over here is whatever the hidden 2 that I have over here. So for this hidden 2, I'm applying it to another layer. So this is the sub. I'll say it as sub output layer. For this sub output layer, I'm sending this H2. So this is how the architecture that I've given. So you can clearly see I have the two inputs and I'm performing the concatenation, and for one output I'm getting the input from the concatenation, and for the another output I'm getting the input from my H2, that is hidden 2 layer. So this is crazy, isn't it? It's not a straightforward layer. So if I want to write these kind of custom layers and have my own architecture in such scenarios, creating the model as a subclassing API is really going to help us. So let's look at our code now. Now I'm just going to execute my cell. Okay, I'll have to first import it. So let me import it again over here from above. So I'll just import it. So I'm going to import my Keras first from TensorFlow, and this is followed by I'll be executing the below one, guys. Okay, so we have created the model, guys. So the code has been executed, and here if you look at it, yes, I've created a model object. Model is equal to my model, and I've mentioned what is the number of neurons and what is the activation. So I've mentioned the activation as ReLU, and this has created the model. Now if I say type of model, so this is of the type of myDeep model, which is a class, actually a class. You can clearly see it's a class. So it says main myDeep model. All right. Now, one of the common thing that we would normally do is when we create a network, so we'll say display the summary. Now let's see what will be the output when I display the summary. See, I'm getting an error. The error says this model has not yet been built. We have to build the model first by calling the build or by calling the fit with some data, or specify an input shape argument in the first layer for an automatic build. So this will be a disadvantage when I'm performing this subclassing API. So when I'm building my own model using this custom class, it will be very difficult for me to debug it. So if I want to test out, I have to first apply my data and then I'll be able to check, okay, whether all the layers are in correct shape or not. So, but in case of the existing Keras layers which we have seen earlier, or the other three methods that we have seen earlier, in that method, it is easy for us to debug. We can analyze in which layers, how many number of parameters that I'm having. We have more control over there when it comes to analyzing the data. But here in this scenario of subclassing API, I'm having more control when it comes to network architecture. So this is one of the advantage and a disadvantage that we have when it comes to subclassing API. I hope this video has been helpful to you. So please subscribe to our channel if you are new to us. Alright guys, till then, take care.